In today's notes, we're going to take a look at how to solve exponential and logarithmic equations. In fact, today we're mostly going to focus on just the solving exponential equations, and tomorrow we'll focus more on the solving logarithmic equations, although we may do a little bit of log in today's notes as well. So when solving exponential equations, there's really one question that you want to ask yourself at the very beginning before you get started. And that question is, can the values on both sides of the equation be made from using powers of the same base? So if the answer is yes, you are solving what's called an exponential equation with like bases. If the answer is no, then you're solving exponential equations with unlike bases. And there's different rules to follow for that. Solving exponential equations with like bases is something you would have actually seen last year for sure. So when you're thinking about like bases, think about simple numbers like 2, 3, 5, maybe 7, something along those lines. So as I look at the example that I have here, I've got 4 raised to the 2x plus 1 equals 32 raised to the 5x minus 3 power. When I look at both the bases, 4 and 32, I recognize that both of those numbers are powers of 2. So what I'm going to do, step 1, is I'm going to replace the bases with common powers, common bases. For example, a different way of writing 4 is calling it 2 squared. And a different way of writing 32 is 2 to the 5th. Now that's just replacing the base part. So the 2 squared is just replacing the 4, and the 2 to the 5th power is just replacing the 32. Remember that there was still an exponent on that. So 2 squared, which is 4, was being raised to the 2x plus 1, and 32, which is 2 to the 5th, was being raised to the 5x minus 3. So don't forget to keep those exponents on the outsides of those parentheses. So now what you're going to do next is use the rules of exponents. Okay, 2 squared raised to the 2x plus 1 power, remember you've got to multiply your exponents together, is going to be 2 to the 4x plus 2 power. And on the right hand side, we've got 2 to the 5th raised to the 5x minus 3 power. That's going to be 2 to the 25x minus 15. So now that both sides of the formula are expressed as powers of the same base, the third and final step is these two sides are supposed to be equal and the bases are equal. That means the exponents must be equal. So all you have to do to finish solving this problem is set the exponents equal to each other. In other words, 4x plus 2, which is the exponent on the left, would have to equal 25x minus 15, which is the exponent on the right. At this point, you're going to move all of your x's to the left-hand side by subtracting 4 x's, and you're going to add 15 to both sides to bring all the numbers over to the left-hand side. So this is going to give me 21x equals 17, and to find your answer, you're going to divide both sides by 21. So your final answer for x in this problem is 17 divided by 21, which is kind of a weird answer, but that's what you get. You get what you get. When you're doing powers with the same base, don't forget, if you see one side having, for example, 27, and the other side having a fraction of like 1/9, those both come from powers of 3. It's just that the 1/9 has a negative exponent on it. It would actually be a -2 power because it's flipped and squared. So don't forget, fractions are just some kind of a negative exponent on a normal base. All right, for part B here, if you've looked across both sides of the equation and what you see on both sides do not come from powers of the same number, what you're dealing with then is exponentials with unlike bases. There are 3 steps that you have to follow in order to be able to solve one of these types of problems. Number 1, the first step is you must isolate the exponential. Now the exponential consists of a base and an exponent. Anything else that's added on or multiplied or subtracted or whatever needs to get moved over to the other side. So that's what the word isolate means. It means get it by itself. So step 1, get the exponential to be completely by itself. Then what you're going to do in step 2 is you're going to take the log of both sides of the equation. If the base happens to be e, you might want to use natural log. So use ln if the base is e. Other than that, I would probably use common log in all other instances. All right, third and final step is going to be to solve the new equation. Let's practice on our first example down here. So in example 1, we've got 3 times parentheses 2 raised to the x plus 17 equals 47. The exponential in this problem is the 2 raised to the x. So our first job, is to try to get that to be completely by itself. Step 1, I'm going to subtract 17 from both sides. So you now have 3 times 2 raised to the x equals 30. We are then going to divide both sides by 3 so that you can get the 2 to the x to be by itself. 2 to the x equals 10. This is step 1. We now have our exponential. 2 to the x is completely isolated. In other words, it's by itself. Step 2 is we're going to take the common log of both sides of the equation. So I'm going to take the common log on the left, and I'm going to take the common log on the right. So you have log of 2 raised to the x equals log of 10. And these are, by the way, common logs because I didn't put any little number down there as a base. The third step says now you're going to be able to solve the new equation. Well, remember, what doing the log of the left-hand side is going to allow you to do is to bring the exponent down out in front. So the x now comes down out in front of the common log of 2. And on the left-hand side, you have the common log of 10. And if you'd like to get x by itself, all you have to do is simply just divide both sides by the log of 2. So we're going to have common log of 10 getting divided by the common log of 2. And that will tell you your answer. So on my calculator, I'm going to do that right now. And we get, I'm going to go to, how many decimal places here? I'm going to go out to 3 decimal places. So I get 3.322. And that's my final answer for that problem. Let's practice a few more of those. Okay, so we have example number 2, which is 6 e to the x plus 13 equals 343. So again, the exponential in this problem is e to the x, and our first step is to try to get everything else unattached from that and moved over to the other side. So I'm going to be subtracting 13 from both sides. So we're going to have 6 e to the x equals 330. And then I'm going to divide both sides here by 6. So you're going to get e to the x equals 55. And then what I'm going to do here is I'm going to take natural log on both sides of the equation. Now again, the reason why I chose natural log instead of common log for this problem is because the base on the left is e. When you drop the exponent down out in front, you're going to have x times the natural log of e. Well, remember, natural log is log base e, and log base e of e is 1. So essentially, natural log and e cancel each other out. I know. On the left-hand side, all I have to do here is just take the natural log of 55, and I'm going to come up with my answer. Again, I'm going to take this out to 3 decimal places. So natural log of 55 is about 4.007. Okay, third example. Again, we have our exponential. It's e to the 2x, and you're going to have to divide both sides by 4. So e to the 2x equals 5/4. And you now want to take the log on both sides. I'm going to choose to use common log here. I'm sorry, natural log. I'm going to use natural log because my base was e. This is going to allow you to bring the 2x down out in front. And of course, natural log and e cancel each other out. So 2 times x equals the natural log of 5/4. Okay, my calculator tells me the natural log of 5/4 is 0.22314 something something. And if you want to get x by itself, you're now going to have to divide that by 2. So the answer for x in this problem is out to 3 decimal places, 0.112. All right, number 4. Uh, Number 4 is actually a very difficult problem to solve because what you're looking at here, it has exponentials. You have bases raised to powers, but also you're looking at something that's in the form of a quadratic. So I notice that the leading term has an even exponent, 2x, and the middle term has half of that exponent, and the ending term is just a constant. So I'm actually going to factor this like it was a quadratic and set it equal to 0. So how do you get 4 to the 2x at the beginning? Well, that's going to be 4 to the x times 4 to the x. And for my constants that go behind that, I'm looking for two terms that are going to multiply together to make 2 and add together to make -3. Again, I'm factoring this exactly like you would factor a quadratic. Because it has the form of a quadratic, I'm going to factor it like a quadratic. So one of these is going to be -2, and one of these is going to be -1. You now take each one of these factors and set them equal to 0. So 4 raised to some power equals 2. That's one equation. And 4 raised to some power equals 1. That's the other equation. So the 4 raised to some power equaling 2 means that x has to be 1/2. And the 4 being raised to some power that makes it turn into 1 means another answer for x is going to be 0. So because this is in the form of a quadratic, there's actually going to be two different answers for x that work for this problem. All right, last one, number 5. The exponential in this problem is all of that stuff in the parentheses. So 1 plus 0.08 divided by 12 is my base, and it's raised to the 12t power. So the only part of that equation that I don't want to have still over on the right-hand side is the 4,000. It's currently being attached by multiplication, so I'm going to have to divide by 4,000 on both sides of the equation to get rid of that. 20,000 divided by 4,000 is 5. So 5 equals this 1 plus 0.08 divided by 12 raised to the 12t power. At this point, you're now going to take, you've got your exponential isolated. You're now going to take the log on both sides of the equation. So on the left-hand side, we have log of 5. And on the right-hand side, we have the log of that base, 1 plus 0.08 divided by 12, raised to the 12t power. Remember, you're going to get to drop the 12t out in front of this. So our new equation is going to look like this. Log of 5 equals 12 times t. Log of 1 plus 0.08 divided by 12. Now at this point, everything's on just the normal equation line, and you can now get t by itself by dividing both sides by 12, and also dividing both sides by the log of this 1 plus 0.08 divided by 12. Whatever you do to one side, you have to do to the other side. At that point, the 12s would cancel out, and these logs would cancel out, and you'd have t by itself. So when I put all this into the calculator, I'm going to take the log of 5 and divide that by, parentheses, 12 times the log of 1 plus 0.08 divided by 12. There we go. And I get my answer for t of 20.185. This is, of course, as you can tell, this is one of those compound interest problems. What this problem would have been asking is, if we start with $4,000 and want to end up with $20,000 and our interest rate is 8% compounded monthly, how long is that going to take? So this is a way to solve for time in one of those exponential problems without having to make the graph. We're simply just solving by using logarithms. So we've talked about how to solve exponential equations with powers that have the same base. We talked about how to solve exponential equations that have powers that are unlike bases. Now we're just going to take a quick look, because a couple of the problems in tonight's homework are based on this, of how to start solving logarithmic equations. There are really two questions that you want to ask yourself that are going to determine the methodology that you're going to have to use to solve equations with logs in them. The first question is, how many logarithms are there? How many logs? Is there one log? Is there two logs? Is there three logs? And the second question you want to ask yourself is, where are the logs located? Are they on the same side? Are they on different sides? Answering these questions are going to help lay out a path forward for you to be able to solve. Now, the easiest thing that could happen, which is the only thing that we're going to do in today's notes, and then we'll come back and review this and go over the rest of this on tomorrow's notes, is what happens when you're solving equations with only one logarithm. So if you only have one logarithm, if the answer to the first question is 1, it doesn't really matter where it's located, if it's on the left or the right, because there's only one of them. So what you want to do is you want to apply the rules of logarithms to simplify your formula as much as possible, and then write it back as an exponential equation so that you can solve it. So I'm going to take this 3, and I'm going to divide both sides by 3. So that's going to give me log of x equals 5/3. And then what I'm going to do next is I'm going to turn this back into an exponential. The log doesn't have a base written next to it, so that must mean it's log base 10. So we've got 10 as our base. The number on the right-hand side of the equal sign is our exponent, so that means 10 is getting raised to the 5/3 power, and that's going to be equal to x. So all I have to do now on my calculator is take 10 and raise it to the 5 divided by 3 power, and that's my answer, which is approximately, I'm going to go out to 3 decimal places again, 46.16. 46.416. So turning a logarithm back into an exponential is just one of those things that we practiced early on in the chapter. In this problem, what you want to do is first you want to move the 5 over to the other side by subtracting. So we're going to have 2 times natural log of x equals -1. Then we're going to divide both sides by 2. So you're going to have natural log of x equals -1/2. And then I'm going to turn this thing back into an exponential. Natural log has a base of e. The exponent that I'm going to be putting on that is the -1/2, and that's going to be equal to x. So again, on my calculator, I'm going to raise e to the -1/2 power and find out what our answer is for this. So e raised to the -0.5. As a decimal, I'm going to go out to 3 decimal places again. We're going to get 0.607. And there's your answer. Okay, so tonight's homework does have a couple of problems that are going to be solving a single logarithm and also solving exponential equations. You're now ready to try that homework.